Good evening. How are we doing tonight? This is another live training session that is being brought to you by Unity Technologies. My name is Adam Buckner, and tonight we're going to look at an introduction to Heightmaps, which is one of the terrain tools. What is a height map? What is a height map? Well, height maps help us define our terrain. When we're looking at a terrain, we have a mesh. This is the mesh of a random terrain that we have in front of us in Unity. And that terrain is created of, as a mesh, a bunch of vertices, and we want it to look relatively good. And what our height map does is gives us information for each one of the vertices in this mesh. What we're actually looking at is an optimized mesh. The mesh is far more dense than this, but Unity will optimize that mesh for us. So if we're moving around, you can see that the density of that mesh does change depending upon where we are. So it's being simplified. So let's go ahead and just start a new scene, and we'll talk about, well, I want to show you a height map. I've got some here. There we go. These are height maps. Black and white detailed height maps, which, and this particular one is showing Australia, where the height of the point, with black being the lowest point and white being the highest point. And we have to be careful because we can't just use any black and white image, because if we say, look at this, these craters of the moon, the black and white image is very nice. It might be used as a texture. It could potentially be used to extract some normal map information from it, but it is not a height map because the values of the colors between black and white on that grayscale don't define the actual height of the object. They define more of the texture. Whereas if we look back at the height map that we have of, in this case, Australia, we can see that the mountains are white, the sea is black. Which we will see as we're moving on is that trying to find useful height map data can actually be a little bit of a problem. Because I'm trying to find viable height map data, because actually if we look at most of these images, the transition between the terrain and black is quite stark. And when we go ahead and we look at how this works, it probably won't process out the way we would want it to, and we'd have to do some manipulation. So let's go back to Unity, and let's create a new scene. I'm not going to save that. Go away, please. And so one of the things that I'm going to do for me, for right now, is I'm going to turn off baking, turn off the auto bake, the auto build in the light mapping, because I don't want it to interfere with what we're doing. Is that as we continue to make changes, Unity's lighting system is going to try to keep up with us, and it's going to try to light everything that we're doing. So I'm just going to turn off our build in the light mapping panel, and I'm just going to go ahead and we're just going to deal with just the built-in real-time lighting that we have. Let's create a new terrain. So this is all going to be manipulating a new terrain. So we're going to go to 3D Object, create 3D Object, and create a terrain, create a new terrain down here. I'm going to delete the one that I had in the startup. So we just have something called new terrain. And as we see, that's just a simple flat plane. I'm going to go back into shaded mode. And it's relatively boring. It's completely flat. And let's add a texture to it, see if we can, that'll help us later on. So let's go ahead to add a texture. We're going to go to our paint texture that we've got here. And then let's edit textures and add a texture, because we need at least one texture there to keep it from looking terribly boring. And I'm going to go down to textures. And then I'm going to pick grass A. And we'll make sure that these are, most of these are from standard assets. A couple of these things I've tweaked, and the things that I've tweaked I will make available for you. And so there's our grass A and our grass A normal. And then we'll hit add. And now we can see that our texture is completely, has covered the terrain. So the first time we add that very first texture, it'll be applied to the entire terrain. There is a thing called the Splat Map, which we will talk about later on, which will allow us to mix multiple textures onto the terrain. And at this point, we don't have a splat map. We simply have one texture applied. And the other thing I want to do while we're in here, so we can go and test out our terrains, is I would like to go to Standard Assets, and I'd like to drag in a first-person controller. So we've got a little guy that we can walk around on our terrain. And I also have a little script that will just help us a little bit called hide cursor, which I'm going to go ahead and add to our, why don't you let me do that? Do it down here. So add cursor, and that just simply, a hide cursor that simply hides the cursor when we're playing, so it isn't sitting there in front of us. Now, the last thing I'm going to do is just a little bit of cleanup, is that this particular terrain, and we're going to leave everything at default, this terrain is going to be 500 by 500 units. So I want to center this minus 250. There we go. Great. And frame selected on that. And there's our little first-person controller. And I'm going to drop him down a bit, probably down to about 50, so that when we hit play, that it isn't too long of a fall down to our terrain. So, terrain. Our default terrain, flat as a pancake, and kind of boring. To make detail to our terrain, we've got a whole bunch of terrain tools. We can go back to our select our terrain. We can go to our terrain and height tools to try to jazz it up a little bit. We've got all sorts of wonderful looking tools that we can use, different shapes and different sizes, and try to rough it up. And then if it's too rough, we can go ahead and smooth it down using the smooth tool. But it's a little bit, this takes a lot of work to get it started. It doesn't necessarily look natural. The tools I like to use for getting into the fine detail of working out specific portions of what I want in my terrain and in my area, but not necessarily wanting to go through and clean up the entire terrain mesh. And so the first thing I want to talk about with using of Heightmaps is not necessarily using Heightmaps to bring in specific terrain from, say, real-world data from the various geological survey units around the world. You'll find that all of the major countries have some sort of local, if not global, geological data. Not all of it is in convenient formats for us to import into our games, but with some hoops and tricks, which we probably won't cover in today's session, you can get that terrain data brought into Unity in one way or another. But I think that it's really useful to get started just giving some slight variation to our terrain. Also, it'll give us a good way, as we said, to introduce those height maps to us. So we could, as I said, use tools to be able to clean that up. But let's go ahead and take a look at bringing in a height map. So when you're looking at the terrain and you're in the terrain options at the end, the terrain settings, at the very bottom we have height map. We can import raw. We can also export the current terrain. So if you make a terrain that you like, you can export it as a raw file. But we're not going to cover that again today. We're just going to talk about importing stuff. And while we're here, I want a quick aside on tiled textures, because someone was asking me about this earlier. Is that when you're dealing with tiled textures, there's a difference between technically tiled textures and good tiled textures. If you take a look at this tiled texture, I'm going to change our edit textures again. And I'm going to edit the texture now. And I'm going to bring in our tiled albedo and our tiled normal. And this is bringing it into, let's go ahead and open this up in Photoshop. Looks pretty good. It's a tiled texture. It matches up side to side, top and bottom. There will be no visible seams in it, but when we apply it to our game, we can start to see a definite repetitive pattern. And then certainly when we get down there on the ground level with our player, and we start to look around, and we start to look up the hills, especially if you get above a large flat area, you start to see these grid lines that are part of the texture. So sometimes when you're working in Photoshop and you're looking around, the texture looks good until you actually apply it to your terrain. So it's good to do some testing and just make sure that there aren't any really obvious regular patterns that once it gets into that tiled situation, you can start to see that repetitive pattern in a nice, wonderful grid all across your game. So let's go ahead and go back to our terrain. And then let's replace that by editing our texture. And then let's put back in our grass A and our grass N. So that's our grass albedo and our grass normal map. And if you look at the difference between these two, it's very subtle. But I've just gone through and I've tweaked the edges a little bit more so that there isn't this clear mud path that was around the outside of the texture. So Photoshop is where we're going to go ahead and make our height map. So in Photoshop, let's go ahead and create a new document. Now, what's important here is looking at the settings. This is taking for the document that I made before. So let me go ahead and just use a default paper size, and then I'm going to go ahead and change this so that you can watch me. And I'm using pixels. Now, when dealing with height maps and when dealing with the resolution of the terrain, we are dealing with information that comes in powers of 2. But not exactly. Powers of 2 plus 1. So 248, 256, 512, 1024 for our terrain. But the height map needs 1 extra pixel along the outside. So it's a power of 2 plus 1. So depending upon the size of the terrain that you're dealing with, we need 3, 5, 9, 257, 513, or 1025 for our map. So we're going to make a square to 1025, please. So, and 1025. Let's just do this at 72. We're not printing. So we've got our resolution. We've got our height and width at 1025, and we also want to be in 16-bit. If I get the time, I'll show you what will happen if we're down in 8-bit. There isn't enough information for our height map. And then we also need to be in grayscale. If you end up in RGB, you can either end up dumping the color information and going back to grayscale, or you could just lose one of the color channels because of what we're doing. Okay, so that's our document. Now I'm going to go ahead and catch up on chat. No, you can't make caves with a height map. There are ways that we can do that. I do have some plans to do some additional terrain work, terrain episodes, which we can look at how to make that type of stuff, or we can talk about it in Q&A. You can't technically make holes in the terrain. There are some cheats and workarounds that people have done that you can look for on the asset store. So far, none of them to me looked appealing. There are some good solutions for making things that seem cave-like. They're usually using additional geometry. We can talk about that. It's done quite a bit in certain MMOs. Take a look at Guild Wars 2, and they do a very good job of mixing geometry and an impenetrable ground plane. Okay, so we've got this document, Photoshop document, and it is 1024. And what we need, 1025, excuse me, squared for our 1024 resolution that we're going to import into Unity. And what we need to get is a nice organic feeling black and white texture that smoothly moves from black to white in a realistic manner. And one of the best ways to do that in Photoshop is to go up to filters and to use render and to render clouds. And clouds will render relatively randomized, fractalized images that go from black to white through the shades of gray. To a certain degree, we very simply now have the simplest form of a height map. So let's go ahead and save this. And let's save this into our project. Heightmaps, assets. And then new folder. And let's just call this height map data. And in height map data, we'll just go ahead and save this as our height map 01. Now, this is not a height map. To be able to use this in Unity, we have to save this in a particular file format. And that particular file format is the raw file format. So now that we've saved our Photoshop document, we need to go back and do another save as. Come on. What's that saved? Now we can do another save as, and we're going to save it also into the same folder. But I need to save this as a Photoshop raw file. And let's just call this heightmap 01 raw. And The byte order, as far as I can tell, is irrelevant as long as it matches. So you can choose the byte order of Mac or IBM PC, both in the export and in the import settings. So I'm going to, just because I'm on Windows, I'll pick IBM PC, and we'll have to remember to pick it because both Photoshop and Unity default to Mac. So as long as they match, that Mac and Windows will be doing just fine. So let's go back to Unity. Let's just apply that and close that down. And now we should have our Heightmap data. And in that, you can see that we have our raw file. Now, the raw file you won't be able to look at because of the way that the data is saved. So we have to go back to our terrain data. We want to go to our options, our settings, and we want to import raw down here. And then we navigate to that raw file. And when we select open, we're going to get our import Heightmap dialog box. And we do want this to be 16-bit. We can see that already it's sensed that it's 1025 by 1025. And let's go ahead and change that to Windows. And currently we are using default. So we're going to have a default train width and length of 500. So we're also going to have that in our train size up here. So let's go ahead and import that. And it looks awfully crazy. Whoa! So why is that? Well, that is actually what I was expecting to see. The reason it looks like this, and it's so completely crazy, is if we look back at the Photoshop file, we very clearly go from the darkest value being black, the highest value being white. The highest value is 600 units tall. The lowest value is 0. So this is representing from the highest possible point on the height map to the lowest possible point on the height map. So what we need to do when we're dealing with our data inside Photoshop is we need to crush it down into a small variation that we can deal with inside Unity that looks more realistic for our height map. And we can do that using curves. So if we go to image and we go to adjustments and we go to curves, we can crush our information so that the entire value of that height map, if we look carefully, is going to be in the 10% most extreme part of the range. You can see I've dropped this down here to the point where if we look at our texture, it almost looks perfectly white. If you look very carefully, it's a bit smudgy. So let's go ahead and save this. Again, let's save this in our raw format. And I'm just going to go ahead and overwrite this because we don't need to go back and forth. There are a couple of times where I will want to save options, but not right now. So I'm going to just replace that. Replacing this does not fix our problem because the way that Unity is working with the height map data is it's not keeping a persistent relationship. And you don't want it to keep a persistent relationship because there are times when you want to make changes to the height, to the terrain that you have. So you set the value of the terrain based on the height map. And then once it's set, you can go ahead and you can use your tools to go ahead and modify it. So you can make them taller, you can shrink them down, you can go ahead and make changes to that terrain. So this is changing the mesh data that we have inside the game, but it's not changing our base height map. If we were to replace the height map again, it would bring it back in the last state that it was. We have updated our state. We have a new state to this height map. So if we bring this in, go back to our assets, to our height map data, and to our raw, and bring that in. Again, Mac to PC. And now, that's starting to look like a more viable piece of terrain. We do kind of have a problem, though, because if we go into play mode, our first-person controller is falling into the void because the terrain is far, far, far above it. And that's because remember that we're setting the height map data, the terrain data, from 0 to 600. And we have chosen a value that is mostly white. This means that we have set our terrain to be between 550 and 600 Unity units above origin, because remember, our terrain is centered on origin. So let's back up a step, back to our original clouds here, and then look at our curves, and let's go the other way. So when we're setting our curves, let's go towards black. And as a matter of fact, we can do this numerically. I actually think you don't need much more than 5% range. So we've got a 5% range there. It's down in the dark ranges. It's nearly black. And again, we're going to save as raw. Save that as Heightmap 01 again, 01 raw. Save that and replace it, IBM. And then back to Unity. And again, we're going to replace the data that we have in our mesh. And now, when we hit play, it's below our character. And frankly, that's not so bad. So, I mean, for a couple of minutes of work, we can get the look of, you know, a relatively nice randomized terrain. If it's a bit too lumpy, don't forget we're playing now with our color values, the color values that we have between black and white. So we could blur this to soften it. We could also crush it again to make it flatter. So let's just go ahead and quit out of here and come back to Photoshop. So some of our choices is that we could go to the filter, and we could go to our blur, and we could go to our Gaussian blur, and let's just give it a 5 pixels. And I'm going to go ahead and do it twice. So that's 2 blurs, 5 pixels each. Just sort of, I'm pulling those sort of somewhat randomly out of my back pocket. So that's raw, and let's call this blurred. And I'm going to make some options, and we can go back and look at the differences here. And that's again in raw format in PC. Now I'm going to back up my 2 blurs, and I'm going to go back to my curves, and I'm going to crush it down again. 60, maybe. Again, I don't have any magic numbers for this. It's just mostly for an example. And you can see even, maybe you can't see, but even less data there in that black and white map. So let's go ahead and save that one. And let's save this one again in raw. And then let's call that one Heightmap 01 raw. How about crushed? So back to Unity. And let's go ahead and focus on that terrain so we can see it. So there's our little quick terrain. And they're slightly different, these two ways of changing our height map data. If we go ahead and looked at the blurred, it generally softens it. It's removing that variation in detail. So when we go ahead and we walk around on the terrain, we haven't changed any of the hills themselves. We haven't changed the total height that much between the highest and lowest point, but we have smoothed out that surface. On the other hand, we could go ahead and use the crushed import raw. And in this case, we have all of that fine detail that we had the first time, but the total height between the highest and the lowest positions are a bit lower. And so we're starting to begin to look like we're, what, on the moors of the heather of Scotland, that sort of thing. I don't know. It's been a long time since I've been up there, but generally, you know, we've changed the general characteristics of our terrain, and we haven't done a heck of a lot of work, and we haven't touched any of the actual design or detailed tools that are in Unity. This has all been done by simply playing around with that height map. I'm going to go ahead and catch up on chat, partly because a question is catching my eye. Margariti says, when importing the height map with Windows byte order, my terrain spazzes out completely. The question is how did you save it? Because what's going to happen, we've been saving ours with IBM PC. So let's go ahead and go out of play mode. And I'm going to re-import this same height map data, which I believe was the crushed one. And then I'm going to bring in crushed, but I'm not going to correct that to Windows. I'm going to leave that at Mac. So now I have the opposite form of how I saved it. And it's gone a little nutty. So from my experimentation, and frankly, I haven't specifically asked any of the developers about how this works, but it seems to me that you need to match your settings. So if we go back to Photoshop and we do a save as here, and we do a save as raw, let's call this, because this is the height map crushed, but let's call this Mac. And then we leave this at Mac, and we hit OK. And we import the height map Mac and leave it at Mac. It's fine. But if we import that height map Mac as a Windows, we get the byte order. And I'm not quite sure exactly what the details are here. It has to do with interleaving and byte order. But it's reading the information essentially backwards between the two. So as long as your import and your export is the same, you will be doing fine between the two. So if you save Mac, and it doesn't make a difference really what format what platform or operating system you're on, but if Photoshop is saving Mac, then import Mac. If Photoshop is saving Windows PC or IBM PC, then import Windows. There have been some reports of 1 pixel border errors in the past where people have saved Mac on the PC or PC on the Mac and said the last pixel has gone from whatever the last baseline value is to either white or black. So there is a potential borderline issue around the edge. But I haven't seen that. And I don't know whether that is just purely because of an issue that's been solved or some other particular use case. But so I'm currently, for today, I'm saving as Windows. So I'm saving Windows on a Windows and opening Windows, but just make sure you match. So filters. Let's just take a look at some of the simple filters that we can do. I'm going to create a new document. You've saved all of my information. So we're 1025, 1025, 72, which is irrelevant, 16-bit and grayscale. So we're going to save that. And then let's go ahead to our filter and we're going to render some clouds again. But when we're looking for random but organic textures, we can also start to play with anything that's going to be manipulating the image that we have. And you've seen how we can crush that value using curves to keep the entire information in the image into a small narrow band so that it looks more realistic. But also there's a whole bunch of other filters that we can use sort of at random. I picked a couple earlier today to see if they would work. And it's worth pointing out that there are a couple that in the filter gallery that will not work when you're in 16-bit mode. So you need to do them in 8-bit mode and then go ahead and push to 16-bit. But let me quickly look for Solarize. The reason why I picked Solarize is if you notice that Solarizing now puts some very strong, distinct ridges through the image. And the nice thing about that is it starts to give us strong, distinct ridges that we can use to, say, form ridges in our terrain. So doing nothing but a Solarize, and then and you can see what it's done here. We just don't have any information that's below halfway. And then crushing that back down to, say, let's just say 90 at this point. Still give us some height, and then save this in our raw format. Let's just call this height map 2. And I'm just going to do, out of habit, IBM PC. And back to Unity, and then let's go ahead and import that Heightmap 2. Not as quite as stunning as the random example that I had before. We're starting to see those ridges. I'm going to quickly, just forgive me a moment, I'm going to go back and I'm going to uncrush this, so give it a little bit more height. So we have some more mountainous regions, because I sort of had something I wanted to show you. Hopefully, maybe we'll just go back and try this again. Let's just make some new clouds. So I'm going to render clouds again, and then I'm going to solarize that. And then I'm going to crush it back down, but maybe more along the lines of 80. Just give us some more height. And then, again, save that in our raw format. And I'm going to overwrite raw too. And then importing that Heightmap data raw too. There we go. That's a little bit more definitive. One of the frustrations I noticed with this was that if you look at the top of the peaks, you're starting to get some, much more mountainous feeling. But again, because we're going from black to white, all of those ridges are at exactly the same height. So looking back at Photoshop, what can we do to mitigate this? Well, we can create a new layer, if our menu gets out of the way, and then we can just add more clouds. And then on top, let's go ahead and try and overlay. So save that, cancel, let's just save as, so please save that. And then raw, oh no, I didn't crush it down, excuse me, rushing ahead. Let's go ahead and crush that down to, again, about, what do we think, 80, 85, 80. Let's do 80. See what we get. And do a save as. And replace that raw height map. And import that now that we're here in Unity. And now we've got some more variation. We still see that, some of those ridges. And again, I'm not going to get into a lot of the detail here. I think that second level of clouds is probably too strong. You can start to play with how this works with the to create the information. Oh, I see what I did. I only crushed the top layer. I should probably crush the whole thing. I'm going to move on because you'll see I'm going to do one more step to this, and you can start to see some of the fun things that you can do. So I'm going to back out of that curve. I'm also going to back a little bit out of the opacity here so we can maintain some of these strong ridge lines. And also, I'm going to flatten that. And then in my crushing stage, I'm not going to do a completely linear crush. I'm going to grab this curve and I'm going to shove this up with a bit of a curve like that. So we're going to make large black areas that are also going to have a nice gentle curve to them. So when we save this in our raw format, and I'm going to replace that one. Back to Unity, and then let's go ahead and import that Heightmap data. We're starting to see more curves at the bottom of these mountains. It's still a bit strong, a bit high. And if we didn't quite go far enough, because I'm going to go back and try one more time, because I'm looking for a specific bit, which if you can bring this up, let's try 85. And then again, I want some actual bits of absolute black right up here at the edge. So we'll try making that a little bit darker, because what you can get, a little bit too much. Come on, back out of there. My little sensitive mouse. All right, we'll overdo it. Too much fussing. So let's save that to a raw file. Back to Unity, going ahead and importing that Heightmap data as Windows. A little bit too much. Like I said, I was having a hard time getting that specific middle level. If you can get the curves right, but you can imagine fussing with that a little bit longer than I am. You get a flat part, which you can then go ahead and throw in some water. So I've got some standard assets. I've got our water assets, daylight water. And then let's go ahead and stretch this out. The one change I'm going to make is our texture size for the reflections. Pump them up a little bit so they look kind of nice. And then we're a little bit too far down, so let's bring that water up on our position maybe by 1. Yep. Shallow C in this case. Now, our mountains are way too strong because I haven't had a good chance to play with them. I want to talk about a couple other things, but you can see that by manipulating the information that you're getting out of the Heightmap data, you can start to get some more interesting and realistic terrain that you can just fuss with. And you can see that we haven't been fussing with this for very long at all. And we can soften this, we can blur this. And one of the things that you can do also is don't forget that once you're done getting your base height map, you then go back and you play with your tools to go ahead and you can smooth that stuff out here. Using the smoothing tool, you can go ahead and build specific spots for your characters, whatever that is that you want to be doing. So before we wrap up, I want to talk about one other thing, which is Heightmap data that comes from terrain generators. There are quite a few. There's World Machine and World Composer and a whole ton of machines that the pieces of software that do essentially what we're doing in Photoshop, but with far more complicated tools. So as opposed to just coming into Photoshop and sort of tweaking things around to get your organically shaped black and white map, they have large algorithmic solutions to things where they can look at slopes, they can look at where a water level is, they can add erosion, they can add specific types of erosion based on climate, based on whether it is underwater, above water in the mountains. You can, whether it's wind erosion or water erosion, and then also it can look at your terrain and go ahead and assign your Splat Map images. So we looked briefly at adding the texture at the very beginning of this session. So I want to go ahead and add a few more textures. And for the example that I'm going to show you, I need to actually have 4 textures assigned. So I'm going to go ahead and add more. And when you add more textures, you will, oops, that was an edit. How about an add? You can then mix these using the painting tools. So let me go to our textures and let's add, say, a grass texture. I don't have a normal map for that. So I'm going to get a grass texture. I'm going to add, may have left that in standard assets. I have environment, terrain, cliff. And then I'm going to add another one, which is going to be our environment, sand. Now, I'm not going to paint this on just yet. I'm just setting this up, and I'll show you why. So what I have out of World Machine, I have some World Machine data that comes from an application. And so this is if you are working, this is just sort of a final cap to this, is if you're working in another application that goes ahead and creates a height map for you and creates a splat map for you, how to go about incorporating those into your terrain. So incorporating the height map is just the same. So we've got a height map here, it's in raw format, and then we have the incorporated splat map that has been created by the application. And then we also have a small script that I need to put into the editor into the editor folder, which will help us swap out our splat maps. So let's go back to our terrain and import another raw file. But in this case, we're going to go to our world machine assets. And then because this is not listed as a raw file, I have to look for all files. It is raw, but its extender is R16. And I believe it is Windows format. And if it's not, we're just in big trouble. Now, this particular piece of terrain is, in my opinion, a bit too tall. And this was just taken out of the defaults, so it's not going to line up exactly. So its minimum value is relatively high, its maximum value is relatively high as well. So I'm going to do a small change here in our settings by changing our terrain height down to about 300. So that just gives it a slightly more relaxed feeling. And then let's go ahead and grab that terrain and shove it down. Don't know if it's got any good coastline. Does it have any good coastline? Not really. It's just like I said, I just threw this out of the free version with some defaults, mostly so I can show you how to replace splat maps. And it comes with a splat map. Now, terrains incorporate splat maps, which allow you to paint multiple textures onto the same surface. Now, in our case, we only have the one default texture that we've laid down. And we don't see a splat map, which is usually a child asset of the terrain. And that's because Unity won't waste the resources and won't create a splat map until we have more than one texture. So there is a little bit of a workaround that we have to do here, which is we actually have to paint a secondary texture onto our terrain. And like I said, we can mix these, and there's various forms of the brushes that we can use for if we really want to be more delicate, and if we really wanted to, paint, our cliff face and have it look a little rocky, we can go ahead and we can paint our own textures which use the splat map. But I'm going to go ahead and import one that's been created by World Machine. Now that I've painted, I also have to save my scene, and go ahead and watch what happens to the new terrain asset after I save the scene. I'm going to go ahead and save this. Let's just call this main. I'm just going to throw this into the root assets directory. We can see that the terrain asset, now that it has been saved, has a splat map. So not only do you have to paint something onto the scene, onto the texture, you then have to save it, and then we get our splat map. And that's the splat map that we want to go ahead and replace. And it has been created for us by the World Machine tool. And to get our splat map into the terrain splat map, we have to do this using a script. The current script that I have is supplied by World Machine. Most of the applications that are optimized for Unity also supply these, and I will probably make a C# one that I'll include with the CMS page, because I didn't realize until a little bit late that this is JavaScript, Unity's JavaScript. So there is a replace splat map script. It's an editor script. And without going into great detail, this particular script simply goes and looks for the splat map that we give it and replaces it. And please come to the front. Oh, you're over there on another monitor. Hold on a second. Phew. We will see this and I'll do this in C#. It's very down and dirty, rather quick, and essentially it's a little wizard that looks for the texture that's attached to the terrain, looks at the texture that you supply it, and then swaps out the pixels and goes ahead and saves it. So we're going to go ahead and do that. One of the things that you have to make sure that when you have your map that comes in from another application, you need to make sure it's imported under the advanced setting. You need to make sure that it is ARGB 32, uncompressed, and that you have read-write enabled so that you can go ahead and read this and put it into the proper splat map. And then the little utility is relatively straightforward. It pops up a little replace splat map editor window. You put in the new one. You identify the terrain. Oops, I needed to apply that. Sorry, just because I fussed with it. That was the me fussing with the splat map, and I didn't change any settings, but it got marked as dirty. And I'm going to do one thing wrong here just so that you can see it. The terrains that come into Unity, depending upon what package you make them, a little bit like the Mac and PC byte order, or the IBM PC and the Mac byte order of raw files. The order left to right can also be reversed depending upon the package that creates the mesh. And so in this case, we can see that the mesh isn't lining up with our texture. So either we need to reverse the raw file, so take it into Photoshop and reverse it, or what's going to be easier is I'm going to re-import that splat map. I'm going to replace the splat map. I'm going to choose the new splat map, and then I'm going to flip it on the vertical, and we can see that it now lines up. That texture now lines up with the terrain that we have created from our. Oh, and it's too tall. So let's lift up our first-person controller back up to about 100 again, because this particular terrain is relatively tall. Boom. Okay, there we are. And we can walk around our terrain. Now, one last little bit is that if you look at the way that these things are generated, is that you'll occasionally find sections where the triangles along a seam get a little bit like the back of an alligator or a cheap dinosaur. And you can come in with your tools and smooth those out. So those are smoothable once you get your main height map imported. Then you can break out the paint tools, and you can start to clean up some of these seams and edges if they don't look good enough for you. So anyway, that's a quick introduction to Heightmaps, taking a look at how you import them, how you create them in your image program, how they are applied to the terrain mesh, and then a little bit about bringing in height maps that you have created from third-party software. And I suppose the next step, which we will get around to eventually, would be showing you how to put stuff out here on top of this wonderful terrain so that you can then go ahead and make your game. So I'm going to turn this over to Q&A and pay a little bit more attention to what you guys are doing over there in the chat. First, let's start off with anything about height maps or terrains, and then after that, let's move on to anything about Unity while we're here doing Q&A. Caves. Well, we can talk about caves. Caves. Let's see if I can find some rocks. It's actually the question. Do I have any rocks here? To make caves, you need additional geometry. And let me just see if I have a rock. If not, I can try to go and get some. Didn't think about getting a lot of extra geometry. I'm trying to figure out best way to do that. Well, give me 2 seconds. The basic idea is that terrain makes very good soft assets. I mean, soft background. It's dirt, it's sand, it's things that have accumulated over time, piles of leaves. It can occasionally do rocky cliff faces, but it isn't great for doing rocks. It isn't great for doing, well, some certain caves and cliff faces. And that's often better to be done out of geometry. Let me see if I can find some rocks here. Actually, I'm looking at another window on the asset store to see if I can grab something that isn't going to be a huge. I know that Viking Village has some rocks. I'm just going to see if I can grab just the rocks without grabbing everything else. And what you can do, and I've seen this in several MMOs, Guild Wars 2 being one of them, where they do a very good job of blending hard rock assets, which are additional geometry, in with the the impenetrable terrain. And it actually makes the caves themselves feel good because they've got terrain as their base layer, and the ceilings and the walls are all done with rocks. And if you want to layer your terrain, you can make an additional terrain piece of geometry that goes on top of the rocks. So you get a very definite sense that of rocks and caves, let's just say, using geometry. And I guess the point I'm making is that if you're willing to put a house on the terrain and you're willing to put a castle on the terrain, you should also be using rocks and cliff faces. Should be out of geometry that you've modeled and designed. So let's take none. Need animations, lighting, materials. Why don't we just take models? This may be a big import, and prefabs. We don't need scenes. Don't want scripts. Hopefully we don't need shaders. If it breaks, we will come back. I don't want water or image effects. Textures. Okay. Let's see if this breaks the bank. And see if I can find some pictures. Well, let me show you some examples. Now, you're bearing in mind that this is not a Unity game, but it does show what can be done in Unity. Let's see if that's big enough. Where you've got your terrain at the bottom, and then terrain at the top. And so this is a dip in the terrain, and then that's geometry. Now, this is an in-house engine from ArenaNet. But we can do exactly the same thing. So you would build your rock geometry, and then you would put a dip in your terrain using the terrain tools, and then you would then embed that rock geometry into the terrain itself. But that's the basic idea, and it's not unique to Guild Wars. Other people have done it as well. And again, so this is terrain here at the bottom section, and then custom geometry, rock geometry around the outside that gives you that sense of being in a cave. And if you really needed to, and you wanted people with the terrain engine working with trees implanted on top, you would then make a second terrain that you could just layer on top, because there's no limit to the number of terrains that you have that you can put into Unity. Kited Ninja, does anyone know any reasonable free resources for terrain height maps, or Google Images are the best option? What I would suggest is you actually start looking for government agencies that produce proper height maps. There are some hoops and tricks that you need to do to get them through a pipeline, usually to get the data out and into a black and white height map format that you can use in Unity. And we won't be going over that in detail. That also may turn out to be Google is your friend. But to get real world height map information, then I would look at the American government, the European government, the British government all have geological survey websites. They supply copious amounts of data in many, many different formats. Then I would pick your source and then start sort of Googling how to get this into a raw file or a black and white file format. The other thing to look into is, and I don't really have a recommendation at this point, is to look into terrain generators, because there are a number of terrain generators that you can create your terrain in that will then output height maps. That this particular one that we have in the background was created by World Machine, and they do have a limited free version, which, if I remember correctly, means that your height maps are limited to 513 by 513. And so if you want larger height maps than that, then you need to buy their professional versions. So I would definitely be looking at either government data to get real world information, or I'd be looking at a terrain generation package like World Machine or TerraGen, Scape. There are a number of them. Okay, so I found a little dip in the geometry, which I thought might make a good cave. And so what you're going to do is grab a boulder and just to drop that into the scene. Like I said, we're only going to work with one rock. You can come up with your own geometry. And this particular rock, I'm going to go ahead and manipulate to make into the cave that we're going to be. So I'm going to just go ahead and scale this up and use this for the geometry. Now, if you were to be making your own geometry, you would probably not repurpose a single rock, but you might make a more complicated piece of geometry and go ahead and make that more cave-like. I'm going to sort of pile up a bunch of these boulders and until it starts to look like a cave. Oops, what have I done? That. Oh, I got the sub boulder underside. There we go. There we go. So it's just generally mushing these around and making them look like they're trying to be part of some natural rock outcropping that would have just been here. Ooh, got it again. Grabbing that child there. So I'm going to use the same piece of geometry for the whole thing. And just try to make it look like a natural rock formation. Like I said, if I was to do this properly for a game, I probably would be designing more modular, more cliff face style bits of geometry rather than just trying to manipulate this using a boulder. And there's the little exit that I talked about. There's a little exit down the back there, which I ended up burying. Because it didn't really work the way I wanted it to. Come on, you can duplicate. There we go. And something along those lines. So, and then try to make it, look as natural as you can. And stretch that one back a little bit. And then when you're in your shadow distance, we haven't baked anything, so that's just dealing with live shadows and dealing with our shadow distance. When you come close, it's pitch black inside the cave. So we're going to go and pop in a little bit of a light inside the cave just so that we can see it when our character is moving. So let me go ahead and create a new light, a little point light, and let's just pop that in to the back of the cave. Like I said, someone's got a torch. Someone's got a torch in there, and let's bring out its range. Let's just double its range to about 20. And see what we've got in there. So it starts becoming a little bit more cave-like. Completely unnatural light source. Oops, not that one. Let's take the boulder. Okay. And then I'm going to change my mind about this. The other one is that I was feeling that total dirt rock face there wasn't quite working. So let's give it a bit of a rocky ground as well. There we go. And let's bring our first person controller. Where's our character? There we go. Let's bring him over so we don't have to walk across all of this this stuff. There we go. So let's play that. And there's our cave. So you're manipulating your geometry. Completely fictitious light source, like I said back there, nothing real that actually exists, but it lights that up. If we were to use global illumination with this bright light out front, a reasonable amount of light's going to bounce into that cave once you use the GI. It'll bounce into the maybe I don't know how far it'll reach the back, but it'll certainly light up this this front end quite a bit. But this is now just nothing but the hard shadows from the real-time lights. So when you're dealing with your geometry, you're going to also want to have details. So it's not just rocks and grass and that sort of stuff, but you're going to want to build in cliff faces. You're going to want to build in caves. If this cave structure was big enough, let's imagine that we turn a whole chunk of this into a cave structure. And you can also push down when you're using your tools. When you're using your terrain tools, you could, significantly push in quite a bit. So you can make quite a big dip. So you could have an entrance. We're not going to see what I'm building under here. Maybe we'll go underneath and see. You'll just get the idea. So, too far. So you can make quite a big dip underneath here. For the cave could go down quite a ways. And then you cap this whole area. And if it was big enough, you could put another terrain piece on top with grass and trees and that sort of stuff, like a cap. Yeah, the colliders on these are not meant, they're simplified and they're meant to be small. These are, what scale are these at? Quite huge. And so the simplified collider on these is mesh collider. So it's much smaller. It's scaled a bit differently. But so when I've made them that huge, it's a bit incorrect. What we probably could do if we wanted to is take our boulder with our mesh collider and then use the main mesh rather than the simplified mesh. Not quite sure how they set these up. So let's add that component, physics, mesh collider. And then, it's using its own mesh in that case. Would be better if this was set up to use a prefab properly, so that we're not fussing around like this. But well, these are the old what? Cool. Now that we've dug around inside, it's going to look particularly horrible when we go ahead and play. Because I've been digging around inside that cave. Oop, I must have missed the collider on that one as well. But, like I said, you can get the idea of what it is that we're trying to do. Yeah, missed that one. on top of the rock rather than in the middle of it. So anyway. Ooh, that's where also we've got under the rock. No, don't fall on me. Anyway. Frivolity and silliness. Yes, it would be better to use simplified colliders rather than the mesh collider as they stand. Also, it would be better if we use these not to use the colliders that not to use the same mesh. So if you can't use a box collider, you can't use a capsule collider to any effective use, then it would be best to come in here and use a simplified version of that geometry, which I think was what they were trying to set up. Because if you look at the boulder prefab, and again, I haven't set this up, seems to have a collider piece of geometry that's a simplified version of that mesh. But yeah, it's called Boulder Collider, but I don't actually see the collider itself. And that's the prefab. So it also could be that I monkeyed something when I did the import, because I didn't pull everything down that I should, so I may have left something behind. But if we had our mesh collider like that, we could be using that mesh in the mesh collider rather than the high poly mesh that the boulder itself is. So, I mean, actually, you'd want that back inside. So we could use that instead. Point 96, the answer is yes. Do terrains, other than the cave stuff, do they work nicely with raycasting and return the actual normal of the terrain, or just the normal that is up? They should hit the normal of the terrain, as far as I know. I had made a painting tool that was for painting items onto the terrain, and it seemed to work fine for raycasting, and I was even getting it to the point where I was making little tiny brushes. There is an option for normal and matching the normal, and it looked like it was working as expected, but I didn't test it a lot. Kited Ninja, I asked earlier, but do you have a preferred way of getting two terrains to line up? There are ways of doing it programmatically. I know that there is a product called Stitch Scape that's been around for quite a while. There may be other ones as well. Let's see if I can find it. Which is part of Scape. Ooh, where'd I go? There we go. And this is a tool specifically designed for stitching multiple terrains together and getting them to line up. I have not looked at the way to do this. This has been around since 3.41. I assume it still works. It seems relatively inexpensive, but there are ways of looking at the seam and finding a way to put those together. I created a simple square island as a height map, but in Unity it's imported as two halves of a square. I've actually not seen that, but you can get reversal on one of the axes, which is what we noticed with the image, which is that why that script gives the option to flip, they say vertically, because if you don't, then the terrain map is reversed, because some of the machines that produce height maps end up being flipped along the z-axis. John, is there any point in having terrain tools for 2D? I suppose if you wanted a background that looked like this. But, I mean, they are 3D tools. So I'm not quite sure how you would use them in 2D unless you were using them somehow to create a background. Hard to say. Not sure why you wouldn't want to paint that, because there is a certain point where if you were doing that, you might want to do it offline and then take a still image, because it's going to be a lot less information than all of the mesh data that you have for the mesh and all the rendering that you need to do that. Lowry-san, we did talk about importing the raw file to create the terrain, yes. You can export it. The question is, can you export the terrain as well? Yes, we did cover that. But if you select the terrain, you can go to Export Raw. And you got your choice of your 16 and 8-bit and then also Mac and Windows order. And then you just export it to a file. Okay, and then terrain export. And then open with Photoshop. And then we've got one channel, 16-bit PC, 513. Okay, that's it. And then it saves out the same way as we did before with just raw. All right, well, looks like we're winding down. Any more questions? Anything that I haven't answered? All right, well, then I'm going to go off mic. I'll stay in the chat channel for a little bit. Thanks for coming.